I will discuss in this video this problem here, or this two activities, these two activities. But Bayar, you should not confuse yourself. You're asking about the definition of differentiability, and you mixed up with the definition of continuity. Definition of continuity, he asks me if a function is continuous at a given point, yani at x equal a. At x equal a. To be continuous at x equal a, limit of f of x at x equal a plus should be equal to the limit at x tends approaches a minus of f of x, and should be equal to f of a. And that is at a given point. For example, here at a given point, the function, the limit of the function approaches this point, means x equal 2, for example. As x approaches 2 minus, it should be equal to the limit of the function at it approaches 2 plus, is equal, both are equal to the same point, which is f of 2. If this equal to this equal to f of 2, this means yes, it is continuous at this point. This is for continuity. Now differentiability, which is not our example here, but differentiability, he asks how to, if the function is differentiable at a given point. We do what? The definition of differentiability is the limit of f of a given point. I'm checking if it is differentiable at that point, plus h minus f of a over h, as h tends to 0 minus. This means the function, we discussed where the function tends to a plus 0 minus. This means a minus. It should be equal to the limit of the same thing, f of a plus h minus f of a over h, as h tends to 0 plus. This is the definition of differentiability. Means as x tends to a minus and as x tends to a plus. But at this definition, now if it is differentiable at a point, this means it has a tangent at that point. This means for sure it is continuous. But if it is continuous at a given point, does not mean it is differentiable at that point. Now let's see this example about continuity. Consider the function whose graph is shown at the adjacent diagram. Which of the following statements are true? First, if f is left continuous at x equal minus 1. Before that, let me say something. At a point we can discuss directly, because we take the left of the point, the right of the point, and the point itself. They are all should be equal. Now, if we need to discuss if it is continuous at open interval AB, whatever this open interval is, it should be continuous at every single point on that interval. And notice it's an open interval. This means it's not continuous. A is not exist in this interval and B is not exist in this interval. So any point after A and below B, we should discuss this. Now, to be continuous at closed interval, it should be continuous at every point on that interval AB, which is the open interval AB, but we have two more points in the closed interval. This point, which is, it should be differentiable at A plus, means to the right of this point and to the left of that point, because A and B are already exist. We need to study the differentiability at A plus and the differentiability at B minus. Sorry, not differentiability, continuity. Now you confused me. We need to study the continuity at A plus and the continuity at B minus. If it is continuous at all AB with A plus and with B minus, then it is continuous. Now, is F continuous to the left at x equal minus 1? This is minus 1. Is it continuous to the left? This is minus 1. To the left of minus 1, we have this point, right? So it is continuous. So this one is true. Is it continuous to the right at x equal minus 1? At x equal minus 1, to the right of minus 1, here it's not clear, but we have a hole. It's not clear, but we have a hole here. Okay, so is it continuous? No, it's not. So this is false. Is f continuous at x equal minus 1 exactly? To be continuous, again, at x equal minus 1, limit at minus 1 minus should be equal to the limit at minus 1 plus should be equal f of minus 1. At minus 1 minus, it is minus 1. At minus 1 plus, it is 1. They are not equal, true, false, then directly this one should be false. Now, is f continuous on minus 3 minus 1? It's an open interval. Open interval, minus 3 minus 1. From minus 3 to minus 1, the function is continuous. It's true because it is continuous at every point on that function. On that line, we have continuity, so it's true. Is f continuous on closed interval minus 3 minus 1? It should be continuous on open interval, and it is continuous at the open interval. And it should be continuous at minus 3 plus. Yep, it's continuous at minus 3 plus. Why? Because minus 3 included in that function, in that interval. And at minus 1 minus, also it's included, so it's also true. Is f continuous on open interval minus 1, 1? Minus 1, 1. The open interval minus 1, 1. Is it continuous? Is f continuous at this function? It should be continuous at every point on that function. Yes, it is continuous because we don't have any point discontinuous here. You will say that minus 1 we don't have it, but it's open interval. Already we don't have it in our domain, so we don't care about minus 1. But we do care about minus 1 here because it's a closed interval. If it is here, we have to see if it is continuous at minus 1, 1. All the points from minus 1, 1 are continuous in the open interval minus 1, 1. And at 1 minus, to the left of this end of the interval, it is also continuous because we don't have any hole. But is it continuous at minus 1 plus? No. It should be continuous, we said here, open interval, at minus 1 minus, at minus 1 plus, at minus 1 minus, and at 1 plus, and at the open interval minus 1, 1. So this function is not continuous because it's not continuous at minus 1 plus. We don't care for that if the function is, if the interval was open interval on both sides, because minus 1, 1 are not, or already they are not in that interval. But minus 1, 1 closed interval, they are in. Here we have continuity. Here we don't have continuity because we have a hole. This means it is not continuous. Now, second one, the same, but we don't have graph. We can check by directly the function without its graph. Is f left continuous at x equal 0? At x equal 0, left continuous means 0 minus. Continuity, we look at the 0 minus. At the 0 minus, right? Is limit of f of x, let's do it. Is the limit, oh, we don't have much time. Is the limit of f of x continuous at limit of f of x to the left of 0 means 0 minus? Is it equal f of 0? Yes, because 0 minus and 0, both we can see them here. Okay, so we will have the same answer. So this is true. No more time. If f is continuous at x equal 0, at x equals 0, it's not continuous. Oh, sorry. First, f is f part B. Is f continuous to the right of 0? To the right of 0 means 0 plus here. If we substitute here 0, it will be 1.